My name is Richard Grijs. I'm a senior faculty member at the Kavli Institute for Astronomy and Astrophysics at Peking University in China. Over the last 10 years or so, I've been very interested in researching star clusters as basic building blocks of galaxies, from very large clusters that you cannot resolve into individual stars. And these days I'm looking at star clusters in great detail to understand their stellar makeup, the contributions of the individual objects inside them, as well as their dynamics, how they move around. The main challenges in the field that I'd like to address have to do with the distribution of stellar masses across the whole range, from the lowest masses where stars form until the highest masses. This is called the initial mass function, and particularly in environments that are different from that in our Milky Way galaxy. So I am using star clusters in so-called low metallicity environments, like the nearest galaxies to Large Magellanic Clouds. In addition to that, we're looking at the contribution of binary stars to the dynamics and the motions of the stars in these clusters, because these binary systems are very important, but no one has actually really looked at them in detail. So this is a key challenge to understand, because star clusters make up the basic building blocks of galaxies as a whole. A few years ago, it was found that if you count the number of very young star clusters that are still embedded in their natal gas and dust cloud, and you then look at the number of clusters that are 10 million years old, you miss 90%. There is a difference of 90%. So the idea was that 90% of star clusters get disrupted within the first 10 million years. This was called infant mortality. Many people have done work on that, including myself, and at this particular meeting actually we've had a lot of debate, because people now seem to believe that this idea of infant mortality is actually not physical, and it may be incorrect from a basic physical standpoint. I think the last word has not yet been said about this, and we still need to understand this in more detail. So the early phases of star cluster disruption are not very well understood at this point, I think. On longer time scales, the motions of the stars inside the clusters themselves will cause clusters to disrupt over time. This is called dynamical disruption or destruction, and this is also caused by the interaction of star clusters moving around in their host galaxies and the stars getting scattered off their outsides. So the effects of the galaxies, the surrounding galaxies themselves, will cause clusters to disrupt over longer timescales as well. Gaia will be particularly important in understanding how the stars move individually, not as a function, not along the line of sight towards or away from you, but along the field of the plane of the sky in the so-called tangential direction. So that way we can get from spectroscopy, we can get motions along the line of sight, and from Gaia along the plane of the sky. So we have a three-dimensional view of the motions of individual stars. In my field of star cluster research, that will allow us to understand these objects, which are fundamental to our understanding of galaxy formation and evolution, in much more detail.